Can you see my screen, please?
We can see it. Yes, sir. We can see it, sir. The screen is visible, sir.
Can you see the PowerPoint presentation?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Good, good, good. Thank you very much.
So let me permit me to introduce you, sir. Okay, sir.
No worries. Please go ahead.
Okay, sir. Thank you, sir. So good morning to all of you. First of all, I would like to express my kind gratitude to Professor Akhtar Kalam of Victoria University to accept our invitation in such a short notice. Professor Kalam received his BSc and BSc Engineering from the Kolkata University and Aligarh Muslim University, respectively. He completed his MS and PhD from the University of Oklahoma, USA, and the University of Bath, UK. He has been a part of Victoria University since 1985. His area of expertise are electric power engineering, fuel cells, and application in cogeneration, power electronics and drives, and renewable energy systems. He has more than 542 publications in his area of expertise. He has also co-authored more than 26 books in his area. Currently, he is with the head of external engagement in the Victoria University. He is currently the chair of Academic Board of Engineering, Institute of Technology, Perth, Australia, and also editor-in-chief of Australian Journal of Electrical and Electronics Engineering. He is a distinguished professor at the University of North South Wales, Sydney, Australia, 3 Indian University, and 5 Malaysian University. So, ladies and gentlemen, please welcome Professor Akhtar Kalam from the University of Victoria, Australia. Over to you, sir.
Dr. Chatterjee and all the delegates, namaskar from all of me from Australia. Namaste, Sat Sri Akal ji. Good afternoon over here. Good morning at your place. And adab and Wanakam. I forgot Wanakam. So to all of you, thank you very much for coming to my presentation. I hope I can share some of my views on electric vehicles. The topic is very, very valid these days, especially you're having this faculty development program on recent trends in electric vehicles. I believe that this will be of great value to you. And you will see it toward the end of my first presentation, what impact it will have in Indian scenario. But before saying anything, I have to mention that with the privatization of electricity supply industry throughout the world, it appears that all the distribution companies will collapse. It appears that everyone will have their own PV panels, their own distributed energy resources, their own resources. So why do we need the distribution companies? That is one thing that comes in mind. And it seems that, especially we are seeing it in Australia, many of the private companies, which are the distribution companies, they are shrinking their workforce. Will that be for a long period of time? That itself is a million-dollar question. But I can definitely tell you, with the coming of electric vehicles, you will still need a lot of power coming from your traditional sources. So that is the start I wanted to make. And I wanted to make that start purely because I want to introduce my subject on electric vehicles and what are the challenges and opportunities for us. Now, if you look carefully at what the things are there, and if you look at it, you will see that we have got all these huge impact that we have got on the factors that is going to be there for EV uptakes, how the adoption will take place, what impact it has on the electric sector, what will be the industry response, how will the industry respond to that question? These are some of the very big question mark. Remember, there's something called V2G, and what is the long-term potential for that? I don't think I'll have a chance to go for the Berlin one, but I do want to, if I get chance, I do want to talk about Australia and India. In particular, I don't want to miss India. And the reason why I say that is because I think that it's important that you understand that. Now, I do want to erase this. Do you have any idea how I can? Yep, you can erase it. Good. Right. First of all, electric vehicle. What does this mean for the electricity sector? The easiest thing that I can think of is that you are going to move from petrol to electricity. That means if you're buying electricity to run your car, your load is going to increase. So my question is going to be, is this going to be a help or a hindrance? Is this a help or a hindrance? What is it? And that is a question that comes in anyone's mind. And is it going to be that? If that is going to be hindrance, then why should we go ahead with that? So, and I'm going to tell you that this is going to be a great help to the electricity supply industry. Let us see what are the different types of vehicle which is there in Australia. We do have 16.7 vehicles in Australia. We do have 16.7 vehicles in Australia. And if you look at it, we have $22 million population. So that means to every 1.3 people in Australia, there is one vehicle. Majority of them are passenger vehicles. 76% are the passenger vehicles. This is followed by light commercial vehicle. Then there are trucks and buses, a small amount of buses. And there are others. Now, the fuel efficiency is about 19 units per 100 kilometers. And you can add 8% annual electricity consumption. You can add to that 8% annual electricity consumption. Now, to let you know what refueling is like, you can fill 40 liters of petrol in your car in 2 minutes. And that is capable of producing 12 megawatts. Now, in Australia, we have done a lot of studies. This is our AEMC, which is the Australian Energy Market Commission, which has looked at impact of electric vehicles and natural gas vehicles, that is the NGV, on the energy market. They have looked at how many electricity vehicles will be there, when will it be there, what will be the impact of electric vehicles, what will be the impact of electric vehicles on the electricity sector. So, but before we do that, let me give you my basic definition. One I call ICE. ICE is what we have today, the internal combustion engine. That's driven by petrol, diesel. Or we might have battery electric vehicle. We might have plug-in hybrid electric vehicle or the hybrid electric vehicle. We also have NGVs, which is the natural gas vehicle. In Australia, we use LPG. In India, you use LNGs. Now, what are the factors that will affect the vehicle choices? And this will very much depend, because this is a very important question, because this is what will decide why should we be going for electric vehicle. This is a very important issue. And let us see. First of all, and everyone knows this, electric vehicle means environmentally friendly. Okay. Are there charging facilities? If there are no charging facilities in your freeway, say from West Bengal to Arunachal Pradesh, if there are no charging facilities, no one is going to drive an electric vehicle. What is the range? How many kilometers can we travel with charging? Can it go 160 kilometers? Can it go 800 kilometers? And you have to look at the fuel prices. You have to look at fuel. Today in India, the fuel prices is 100 rupees per liter, at least 100 rupees a liter. It is higher in some other states. Will this be comparable to the electricity price? Then we have to look at if there is any constraint globally. And the most important thing is what is the battery price? Because the battery price will dictate the vehicle prices. Right in the beginning, I want to mention to you that battery prices are coming down dramatically. The capacity is increasing, and also you will find that the batteries are coming down substantially in prices. You will see that more and more prices are coming down, and they can be used for a longer period of time. When you buy a new car, the batteries in that car, in the past, we used to change our batteries every 3 years. Now you don't have to change the car. Most probably, the battery will still be there alive, even after your car has been written off. So battery ranges and other things have increased dramatically. In Australia, we had thought that we will have a boom of electric EV in the country. Unfortunately, that has not happened. Because very few cars, according to our thing, has come to Australia. And this is more of a limiting growth that is happening in the industry sector in Australia. But I believe that that is going to change in a couple of years' time. And I will show that to you. In the newspapers, we are getting a lot of backlash against the government. In fact, we are finding that people are very much against fossil fuels, and they're saying that, look, let's try and go for electric vehicles. Okay, we are hearing that everyone in the world is getting away from the petrol fuel car. Why are we still not having it? We are still having a debate of how green our electric cars are. So there is still a lot of debates going on in this area. Now I'll tell you about the various type of vehicles which are there. Mitsubishi has got this model, IMEV. This is a battery electric vehicle. It's a small car, you can see that. It's tiny. In Australia, we love driving 6-cylinder car or 8 cylinders car, 4000 cc type of car. Okay, this is very tiny. This has been produced in Australia. Okay, the range is between 90 to 150 kilometers, but the price is $48,000. Very expensive for that type of car. And the payback period is 43 years. And this is a great disappointment in Australia. Nissan Leaf. Nissan Leaf, again, is a battery electric vehicle. Look at the performance range. That is much better, 100 to 160 kilometers. It is more of a sedan, and it's available. The price is also very good, $30,000. And this is a good proof that that performance can be great. Look at GM Holden, General Motors. They have a plug-in hybrid electric vehicle, and this is going to be $60,000. This is 3 times more expensive than your internal combustion engine. Okay, and the range is pretty small, 60 kilometers. Then the French one, Renault, this is a good one because it feels like a real car. This is not a Mickey Mouse. And after driving that car, you think that this is a real car. The price is better. You can swap your battery in 4 minutes. The range is good, 185 kilometers. And the price is only $40,000, which is a lot less than the prices that I told you before. But the real beauty is this one, Tesla. I wish I could have this car. This one is a battery electric vehicle. Look at the range. It is twice as much as all that I've told you, maybe 2.5 times as much. The price, however, is $200,000, 5 times more expensive than the Nissan. A second-hand one is also $100,000. However, that's not the end. Tesla, that has produced a lot of cars. They've got this Model S now, which is a battery electric vehicle. They have got a range of 500 kilometers. And this was available from 2014. There's zero emission, zero compromises, fantastic reviews, selling like anything, has outsold Porsche and Audi in California. And the price is very reasonable, $60,000 to $100,000, depending on the size of the battery. Model X, this is another good one, another battery electric vehicle. This is an SUV, which is a sport utility vehicle. Okay. It has 500 kilometer range. And it's slightly more expensive than the Model S. However, Tesla has come back with a new thing. They're saying that they're going to introduce cars in the next 3 to 4 years, which is going to be $30,000. They're calling it the Gen 3. They're merging with Apple. They've got supercharger stations in 14 of them across Europe, especially the Autobahn in Germany. Okay, we charge for 30 minutes every few hours. So this is a good one. China used electric vehicle, whether it's a 2-wheeler, 3-wheelers, 4-wheelers, whatever it is, whether it is light vehicle or standard 4-seaters, they are solving their air pollution in China. Beijing air pollution was just under Delhi's air pollution. And you will find that in Beijing today, there is no air pollution at all. because they're using e-bikes, e-cars, e-buses, and they are looking at mass production. The other day I heard that in Sydney next year, they're going to start an office selling their electric car here for $15,000 to $20,000. So there is going to be a constraint in supply and the pricing of the electric vehicle. But I want to show you the price difference between the internal combustion engine and electric vehicle. And naturally, there is a premium of $20,000 to $50,000 compared to ICE. And that is because in Australia, if you purchase, you have to pay a premium price. But operation cost is much less. If, say, petrol is at $1.50 a liter, today the petrol price is $1.40. I filled my car yesterday, $1.30. And say it takes 7.5 liters to drive 100 kilometers. So it's going to cost me $11.25 for 100 kilometers. In India, the petrol price is 100 rupees a liter. So that would cost me 750 rupees to drive 100 kilometers. And let us see what's the price of electricity. Electricity in Australia is 30 cents a kilowatt hour, which is the on peak, and the off peak is 12 cents per kilowatt hour. I've just taken some of the maximum prices and say you need 19 kilowatt hours to drive 100 kilometers. So an electric vehicle will cost you $5.70 for 100 kilometers. Off-peak charging, which is at 12 cents a unit, will cost you only $2.30 per 100 kilometers. So if you look carefully, you can see that if I was to say, and I'm just using that as an example, that if I was in India and if my unit price was 7 rupees a unit, okay, I can drive 100 kilometers for 140 rupees compared to ICE, which is 750 rupees. So you can see that even in India, with the amount of price of electricity and diesel that is hiking up in India at the moment, if we had electric vehicles predominantly, our cost would have been a lot lower. And when I talk about lot lower cost, I think I'm talking about 20% of the cost that would take for a petrol fuel engine. So, and I'm going to, if you look at it, the petrol prices versus electricity prices, you will find that carbon price favors the petrol diesel vehicles. The fuel is exempt. And whatever the price is, whether you want to take global action, whatever the petrol prices, whatever the wholesale electricity prices are, you find that the prices are accelerating. In Australia, we believe that by 2040, our prices will not go that high. But in India, it is rising exponentially. Now, if you were to compare the life cycle cost comparison of a small car with low kilometer and a small car with high kilometer, you find very clearly that your battery electric vehicle is much better than the hybrid one. And definitely it is better than your gas one that you're driving at the moment. Whereas in a high kilometer one also, if you look at it, the life cycle cost for a battery one is lowest amongst all the 5 components that I talked about. The petrol one, the hybrid one, the plug-in type, the battery type, and the natural gas type. If you look at the vehicle range, most of them are in the range of 80 to 160 kilometers. Naturally, Tesla is the best one, as I mentioned it, but others are not bad. Average, you can get between 80 to 160 kilometers, which is sufficient for majority of the trips. So people have got anxiety that will my vehicle range be enough to go for my day-to-day activities? And I can tell you, whichever car you take, you can still fulfill all your duties, and the anxiety level that you have is unfounded. Let's see, how many trips do you make? And in Australia, we can say that we make about 72,000 trips in 1 year. And look at that. Half of the trips that we make is less than 5 kilometers. 90% of the trip is less than 30 kilometers, and only 120 kilometers are done by 99% of the trips. And this is, again, remember, I told you up to 160 kilometer range is the average range of an electric vehicle. So it doesn't make any difference. You can still make your trips. A question which is asked is, this is a difficult one. What sort of charging infrastructures are there? And there are 3 levels of charge. Level 1, which is the standard one, and it'll take you 6 to 8 hours, the initial one, and top up is 2 to 3 hours. The fast charge one, total is 2 to 3 hours, and top up is 30 minutes. The rapid one, it is only about 10 to 20 minutes and few minutes for top up. Normally, you do not have a great amount of new technology in this charging infrastructure. For most of the one that we have at homes and commercial premises and public charging facilities, level 1 and level 2 are sufficient. Level 3 is only there where you need quick charge facilities where you can top up in few minutes. Now, how can you do this? You've got a 15 amp plug? Because it's simple as that. You can use any electrician to do this. A level 2 electrician can do this. And it'll all depend on the cost. And I've used 2 different companies, Better Place and ChargePoint. They both have bollard, wall-mounted, and domestic. ChargePoint has got one extra, which is a pole-mounted one. Or else, they all have bollard, wall-mounted, and the domestic ones. The domestic one you can put in your garage. So if you look at that, you can think of indoor location and outdoor location. Actually, the indoor location is much cheaper than the outdoor location. And there are different models available. And I'm using ChargePoint as a supplier, which has got different products. CT500, CT1500, CT2000. And those prices is anything between $3,000 to $6,400. And if you take larger, you get a 20% discount on that. And you can You can think also of installation cost. In domestic, the cost is between $600 to $1,200. And for commercial car park, the cost is about $2,500. And if you have an on-street ballard, that might cost you about $10,000. Now, the important thing is greenhouse emission. Remember, I gave you that example of Beijing. Actually, emission in electric vehicle is a lot less than in petrol-driven. Okay? And this will improve once we'll be using renewables in the electricity market. Because, in fact, you can use 100% green power. And if you use 100% green power, there's no emission at all. Now, emissions might depend on the type of vehicle that you have. The Mitsubishi is a lower emission compared to Nissan. But average, we find that the emission is 15 kg of CO2 for 100 kilometers, around 15 kg CO2 per 100 kilometers. That is the average that emissions is there, depending on whether you have the Mitsubishi one, whether you have the General Motor one, whether you have the Audi, or you have the Nissan. Naturally, this is not as good as walking or cycling and public transport. But electric vehicles do not address traffic congestion and parking issues. And they have embodied energy in the battery and car components. And now with IoTs, and I'm doing a lot of research utilizing IoTs for parking purposes. I don't want to take another hour trying to talk about my own research in this area. But parking is not an issue. Now, you may need to redesign your transportation system, especially your metro trains and all those things. You might have to look at the electrified freight buses and ferries. You might have to use rapid recharging station, catenary charging on main routes like this. You can keep on charging over there. This will have different grid impact. But there is huge amount of opportunities for controlled charging. Naturally, you have to change your design of your carriage too, so that you can fit your electric vehicle into that carriage. And I can tell you, the battery electric vehicle already outperforms the ICEs in high use application. So after saying that, what is the forecast of uptake? And these are just modeling. We have looked at low, central, and high type, okay, in 2015.
Gupta, please mute your microphone.
Dr. Chatterjee, can you tell Dr. Jana Gupta?
Switch off your microphone. Please switch off your microphone.
Thank you very much.
Please switch off your
Could you please
microphone.
shut up? Yeah.
फर्स्ट यूज कर लेंगे तो उनके
प्लीज
जनसंख्या कवर हो जाएगी ना। ये है कि सबको पैर लग जाएंगे, जितने को लग जाएंगे आधे तो सेफ हो जाएंगे।
Yep. Thank you very much, Dr. Gupta. And no doubt about it, electric vehicle is going to be inevitable. It's just a question of how we respond and what's the time. There could be some uncertainty. As I said, by now, we should have had more than 50% of our cars electric. We haven't reached it, but I'm sure by 2030, we will have more than 50% of our electric vehicle cars running in the road in Australia. So depending on which one you have, the blue one denotes hybrids, right? The green says about plug-in hybrid, and the battery one is that orange one. Look at it, slowly and steadily. When you look at it, the battery one is increasing, whereas the hybrid is going to go down. The plug-in hybrid is also going to increase. This is our modeling. Now, what impact will it have on the electricity sector? There could be, again, few things. One could be the management incentives, spatial clusters, size of the vehicle, and the hybrid uptake. The management initiative will dictate the network impact. The spatial clusters will talk about the early adopters communities. I will talk about that in a minute. And the size of the vehicle, naturally, initially there'll be smaller sizes, and the hybrid impact or the uptake, okay, will be in early years, and later on it'll limit. So this will all have impact on the electricity sector. So let us take, for example, if you look at this carefully, you can see that in one day, the maximum load in our 5 states, ACT, New South Wales, Victoria, South Australia, and Queensland, has been as shown over here. And if you look carefully, the 3 states, which is Victoria, New South Wales, and Queensland, their distribution load is anything between 4,000 to about 5,500 megawatt. And whereas in ACT, it's a very small place. It's very steady. In South Australia, also it's a small place. It is not that bad. Whereas, according to us, if it is unmanaged, it's going to raise up substantially. Look at that. We're going to have huge amount if it's unmanaged. And it depends also on the time of use. It depends on whether we have a smart system or not. And very small impact on whether it is controlled or not. So you can see that every charging type will attribute to the increments. So if you look at this central case, by 2030, if you had unmanaged charging, 8,600 additional megawatt would be required. For the time of use charging, it'd be only 410 megawatt, and for smart charging, it'd be about 205 megawatts. So our forecast for additional demands, depending on whether it is the forecast itself, whether it's smart, time of use, and unmanaged, and you find that if it is the forecast, that is the type it is there. If it's unmanaged, it can go, the peak demand can go very high in our country. Now, you will have to have additional cost, and that cost is going to be not evenly distributed between distribution, transmission, and generation. That is $10,000. This is the central uptake, which is the unmanaged charging, and majority of them will be in the distribution sector, then followed by generation and transmission. Now, I told you about early adopters, those who want to get new technology. Those are the ones who will have a very high average income. They have a very high level of education, very above average technological skills, and they're aware of the environment, and they're aware of the new technology. And look at that, majority of them, 40%, will be the early or the late majority who will
Mute your microphone. Please mute your microphone. Yeah, I am him.
Okay.
On your behalf.
Yeah, thank you very much. Now, if you look at the spatial cluster, naturally this is Australia, and our majority of the population is on the east coast, and there's a small amount in the west coast. Perth is over here, right? This is Melbourne. This is the area of Sydney. Here is Brisbane. This is Adelaide. So there will be strong intake in our big places, okay, and medium intake over here. But majority of the country is desert, as you can understand. The eastern coast is where the population is. So that is how the spatial clustering will take place. So there will be some areas where the uptake will be much greater than other areas. And our big cities will have better. Additional challenge. If you don't want to go for level 1 charging at your home, you can't wait 6 hours to wait for your charging. You want it quickly done. If you go to level 2 charging, naturally it's going to become a bit more tiring to get all the wirings done. And one more challenge will be whether our distribution network can meet that demand, especially the off-peak demand. And upgrades can be expensive. In particular, majority of the place which will have it is in the urban areas. And in our urban area, most of the lines are underground. We do not have overhead lines. So when it's underground, upgrade is going to be much more expensive than the
ट्रिपल अरे वो लोग उधर है सीएनसी में गए हाँ
Okay. If you look at this, you find that, say, this is a loading of a 400 voltage distribution line and low voltage network in a metropolitan area where we have assumed that there is going to be 100% e-mobility. You find that the maximum line loading is about 100%, but some areas that could be overloaded, depending on the number of lines. So this is the demand. If you look at South Australia, this is the demand of South Australia, that blue line. And say, for argument's sake, we only allow them to charge in off-peak period, there's enough. There's enough over there. There's enough to cover it. That would be the demand. So literally, it can be accommodated. It'll improve our load factor. In particular, if you look at the load factor, especially, again, the low, the central, and the high region, you find the load factor improves by 5 to 7%, depending on the state that you are in. In particular, I'm talking about 2 big states, New South Wales and Victoria. What will happen if we take 100% electric vehicles? So one scenario is having ICEs, which is going to cost us $1,000 billion. But if we say we have got 100% electric vehicle, this is going to cost us more because the infrastructure cost is there. That extra bit, the EV charging infrastructure, the battery replacement, those 2 things will come in. That extra cost is there. Although the maintenance will go down, the capital cost will go up. So the NPV of total cost between 2015 and 2035 for 100% transition to EV by 2025 is going to be substantial, and we will have to come up with the dollars. So if you had 100% EV, there's going to be additional demand, and this is the additional demand. And that will be enough to take care of any charging. And that demand, if you look at it, that will be in off-peak time. Now, what is the power of choice review? Our Australian Energy Market Commission gave a response to electric vehicles. And they said that this is fantastic. This will give you demand response. It is technology neutral, and it considers the power of choice. And let us see what is the AEMC key priorities. And I don't want to talk about everything else, but two things. One is that the review wanted, the highest priority was that everyone should have the choice. So you have an informed choice on how you're going to use electricity and manage your bills. And the other thing in the retail market is for the electric vehicle, because you might look for economically efficient ways to manage the impact of electric vehicles in the market, whether it is in the residential area or in the commercial area. The other things are still the same. So what is the proposal? And this is defined by the way, the Ministerial Council of Energy. So what is the proposal in power of choice? The distribution service providers, which are the DSPs, can directly participate in the wholesale market, and they can receive the spot price. You can allow consumers to engage with multiple different parties for different services. You can make DSP a part of network planning. You can improve framework for how distribution network tariffs are determined. There'll be overreaching framework so that you can encourage commercial investment in better metering. You can give better access for customers. And there is greater coordination between measures and policies for EE and the distribution service providers. So you will find that there could be a time-varying network tariff. And this is very interesting. There may not be off-peak charge and on-peak charge, because as I told you, that majority of the charging will be done in off-peak period. So your on-peak and off-peak consumption will be the same. So you might find the electricity distribution companies, the DSPs, asking you for the type of equipment that you have, and they will have varying tariffs. That will be more cost reflective. It will depend on the peak demand, and it will encourage customers and retailers to respond appropriately. Retailers have their freedom. They can choose and include anything in their retail offers. That is still there. So what is the components of the electricity price? Look at it carefully. If you look at it, majority of the cost is in the distribution sector and the wholesale sector. 80% of that cost will be time varying. The other things like renewable, retail, state-based schemes, transmission, they are negligible. But 80% of these costs are time varying. And if you look at it, there are three bands in this time. The small to medium residential and small business consumers, they will be in the band 3. Naturally, they are the most vulnerable consumers to be protected. The band 1 will be the one who are not vulnerable at all. But this vulnerable one, which is in band 3, they will be deemed to be on a flat network tariff. And they have the option to move in a time-varying network tariff. So a consumer's retailer will be expected to offer the choice of time. So they might tell you, Dr. Chatterjee, you can charge your car between 4 a.m. and 5 a.m. in the morning. That's all the time that you're given. Dr. Gupta, you can charge between 12 midnight and 1 o'clock in the morning. So it will be like you are not going to wait for 4 o'clock in the morning, Dr. Chatterjee, to plug in your electric vehicle, but you'll have it charged, but automatically at 4 a.m., it'll start charging your car. That is the type of band 3 that will be. In the band 2, which is more cumulative distribution curve, here the consumers again are on time varying network tariff, not like the first one when you were in flat tariff. And they have an option to go to flat tariff if they want. But the retailer is expected to offer the choice of time varying tariff or the flat retail tariff. In the band 1, which is for large residential and small business consumers, there it will be mandatory. There is no opt-out or opt-in preference. Like band 3 had opt-in, band 2 had opt-out, band 1 is mandatory. The consumers moves to a time-varying network tariff. No option is given to that consumer to go for flat network tariff. The retailer may offer a flatter tariff if it decides to manage the impact of time-varying network tariff. That is something that's between a large residential and small business consumer and the retailer. Whereas the small to medium one and the medium to large one have got these band 2 and 3, where they have the opt-in or the opt-out principle. Now a bit on V2G. V2G is becoming a big thing these days because that I believe is there is a lot of potential and a lot of challenges. In particular, EV, which is going to be distributed sources. If you have a large number of grid-connected batteries, can that be used for distributed storage? And can it be needed for integration of renewables? And that's a very big question. Because you need to have a distinction between the managed charging and the V2G, that is supply energy back to grid. And that is something that has to be taken into account. And what is the factor which are influencing them? What will make your V2G a success? It'll depend on the mass of electric vehicles. If you got, say, in NIT, Andhra Pradesh, if there are 200 electric vehicles in there, they can use that to run the electrical labs. So there you can do an aggregation of services. The tariff arrangement should be such that you reward the higher tariff for V2G than the consumers pay. The concern of the drivers, that means you give appropriate return to discharge vehicle and the impact on battery life. There are some manufacturers who think that the battery life, where they have now producing batteries which are going to last between 10 to 15 years, might be shortchanged because of that impact of V2G. All that thing, the four things that I talked to you about, will contribute to the success of V2G. So when you are talking about storage, the first thing that comes in my mind is price arbitrage. Is it going to be on-peak or off-peak price? Because there's not much difference. Okay. What about frequency control ancillary service? And you know that the power system requires that both generation and load are in balance in order to operate safely. If there is a variation in generation without a corresponding variation in load, then the frequency of the power system will deviate. It will lead to stability. At extreme level, there could be blackouts and failure. The frequency control ancillary service is a process used by the energy market operator so that frequency is maintained without the normal operating band around 50 cycles per second. So I can simply say that frequency control ancillary services provide the fast injection of energy or fast reduction of energy so as to supply and demand. And this particular feature of storage is a lot cheaper than the one which is from the national electricity market. You can defer your network augmentation, and this is most likely area of sufficient benefit which can justify cost. And this is largely unrelated to renewable integration. Now, how will you compare EV with large-scale battery storage? And you are seeing in many places wherever there are renewables, wind generation and PVs, that we are putting in large battery banks. This is purely because if there's going to be a blackout, the battery banks comes in. Especially there's issues with integration. And we have seen that in South Australia. We put 100 megawatt of battery plant. We are now putting 300 megawatts of battery plant in Victoria, another 300 megawatts in Queensland. This is going to cost us money. I know we got it pretty cheap, but still is going to cost upfront cost. The large batteries can be justified, especially if you want to defer your network. Operating cost is minimal. And you can use that for arbitrage and frequency control ancillary services also. With electric vehicle, the upfront cost is minimal. It could be an inconvenience cost could be there. But you can have a business case, especially if there's going to be some sort of contingency in the system. Say, for argument's sake, you knew that there's going to be shortage of supply because the demand is going to be very high due to the weather, climate, or whatever it is. Then we could use number of electric vehicles and supply to fulfill the contingency in this case. So EV is providing already contingency for frequency control ancillary services. Okay, you can have different regulation. It could be 6-second regulation, 60-second regulation, 5 minutes regulation. If you have wind or PV, you can lower it. If there's demand, you raise it, right? And by that, electric vehicle is very well suited for such type of situation. You won't have it every time, is rarely called upon, but it will aggregate to provide large quantities. But remember, the contingency services are more expensive to provide, especially with renewables and demand management. This may be the best way where you can reduce your contingency. So when we are looking at vehicle to grid options, the vehicle can supply the grid. There are technical challenges. I'm not saying that they won't be there. But tariff will have to look at this. The vehicle to home, there is no export to grid. This is very simple technically. This is only attractive when the home is on strong time of unit tariff, which is basically critical peak pricing, which refers to a method of pricing electricity where time of unit pricing is in effect with the exception of the certain peak period, at which time period it may reflect the generating and purchasing capacity. Another way to contribute, most significantly, you can contribute EVs by having mass production of batteries. And I told you the simulation of technology has improved, but reuse of battery is something that needs to be done, or else what do you do with it after the battery life is finished? So in conclusion, I can tell you that transition to electric vehicle is inevitable. Whether you like it or not, you're going to have electric vehicle. There is incentive for change. There is potential for significant impacts on peak demand. There has been review on power of choice. And V2G may have limited application, although this is called upon very rarely. With that, I have finished my main presentation. I did want to say a bit on India, and I will just skip some slides. And I'll go to India. I wanted to talk about Australia and India, but I'll skip Australia too. I'll just go to India. In this India one, I want to talk about Indian context, talk about e-mobility and grid integration framework, some of field study results, and what recommendation I can give for India. Whether we like it or not, electrification of clean transportation, charging infrastructure, and the 21st century electricity grid are key components to future-proof global energy security and environment and clean air objective. And for that, India has got this National Electricity Mobility Mission, where they think that they will have 6 to 7 million electric vehicles. They have also got National Smart Grid Mission. They also have primary driver of grid modernization. The third thing they have is renewable generation of 175 gigawatt by 2022, which is 6 times more than what it is now. And they want to reduce their greenhouse gas emission. They want to do that by reducing their coal-fired plant generation by 68%. And don't forget, all that is going to add to our air quality. Look at the air quality. And I just wanted to mention to you the example between Delhi, that is Delhi, my friends, and that is Beijing. Now Beijing has reduced dramatically. Now Beijing has got very little air pollution. Our Delhi air pollution has dramatically increased. So you find that air pollution air quality is very important. It's very hard to breed. Look at that in the northern part of India, especially all the way from Agra to Delhi. Majority of them is in National Capital Territory, in Uttar Pradesh, Uttarakhand, etc. Then Hyderabad, Mumbai, Chennai, Bangalore. You will find that we have to do something to reduce the air pollution that we have. So, why is electric vehicles important? Because we want to focus on electricity market within the context of the grid. That is the transmission and distribution electric vehicle stakeholder system. This is an example of the United States that I want to give you. Look at how the electric vehicles sale has improved, how they have gone cumulatively, the sales have increased, and how much exponentially the amount of plug-in electric vehicle and electric vehicle are in the American market. And by 2022, that is by next year, this will cost the same as their IC counterpart. And this is the best part. The cost of a petrol-driven car and an electric vehicle in the United States is going to be the same. So 35% there will be a global EV share in 2035, which will be 10 times increase in California electricity vehicle in 5 years. You know that they have a zero emission vehicle mandate in California, and that can be done by electric vehicle. There's 40 times increase in California's charging infrastructure. So they've got huge amount of charging infrastructure in public, in workplace, in multiple unit dwellings. Now, the 21st century grid and the vehicle to grid integration, or what we call the smart charging focus for grid integration, which will have, okay, a completely integrated and interoperable power system, you will find that there will be renewables are coming in, right? And that is the classical duck type of curve. Depending on what type of system you're going to have, you will have your, either it will become less deep, that means there will be less risk of over generation. So you will utilize your existing resources. There could be lower peak, which will reduce the need for peaking generation capacity. No doubt about it that battery electric vehicle is used for functions which is driving the needs. But that's the duck curve that I was talking to you about. And look at the domain, look at all the EV and DER management, the charging system, the distribution, which is the community and city, the campus, which is BTN, and building, again, BTM. So there is going to be integration between generation and DER. You're going to see more and more sensors, measurements, control, interoperability, as I told you, systems and devices, new type of tools, new type of decision making and planning, a lot of grid operations and market, security, reliability, and resiliency will be 3 buzzwords. Interoperability. This is because of the potential for EV deviation, lower electric vehicle supply equipment cost, and enable EV grid services. So there could be a lack of EV and EVSE interoperability for power. There could be lack of interoperability supply equipment network. And depending on that, it will all be decided what type of demand and charging will be required. Look at that. That is the extra demand that will be required after charging. So this is a demand response changing at workplace. And if you see that, this is how the change is happening. The software is going to be there. This is what the Southern California Edison did. They provided the software. They did all the testing on different platforms. They looked at the support that they can do. And basically what happens, you have a credit card with you, you swipe the credit card and you charge your cars. So you can choose between level 1 and level 2, depending on how much you can pay. This is a case study where the storage is firmed in the charging station, okay, where the distribution services are from the grid. Then there is a supply infrastructure to the electric vehicle. It's all flowing to the cloud. This is what all the IoTs that I was talking to you about. Again, the Opal Vehicle Grid Integration Platform. This is another one which is in phase 1 at the moment, where they have looked at various innovation, various demonstration, and the various type of things which is there under consideration in the United States. So my last slide that I wanted to mention is my key conclusion. I can tell you right now that we should be looking at BEV technology, that is using V1G. V1G stands for the unidirectional control charging, and the power systems integration can provide market-based dispatch grid resource for variable generation. You have to look at interoperability and the vehicle to grid integration using either V1G, which I said was unidirectional control charging, or vehicle to grid and accelerate electricity mobility diffusion. So this is my advice. India's national mission must consider technical and regulatory challenges. They have to look at case studies, just like I showed you the case studies in the United States, and then design their policy that can give them leapfrogging ahead in EV ownership. The voltage to grid integration lessons can serve as a model for India to accelerate adoption of EVs, decarbonize electric grid, and improve urban air quality. Inter and intra-ministry coordination amongst India, that is the Ministry of Home, Ministry of Planning, Ministry of New and Renewable Energy. They have to coordinate amongst themselves and execute an integrated clean energy and clean transportation goal. Till the time they do not do that, I fear that electric vehicle will have a lot of impediments in India, because till the time the government doesn't work hand in hand with the industry, it'll never go ahead. With that, Dr. Chatterjee, I've finished my first presentation.
Thank you, sir. Thank you for a nice presentation.
Thank you.
Participants, do you have any query, you can ask sir about the first presentation. Do you have any query? If you have any query, you can ask sir. Anyone from the participant side?
I'll come to my next presentation by time people are deciding. There are no questions, Dr. Chatterjee. Can I go ahead, please? Because I'll not be
Yes,
able
sir.
to.
Yes, sir. Yes, sir. You can move.
Okay.
Can
Thank you
go
very
ahead,
much
sir.
again, Dr. Chatterjee, to allow me to give the second presentation. Again, as I told you, now what I want to do, although I've said that in the beginning, I want to talk about what will be the impact of electric vehicle on electricity demand and distribution. I tell you, it's going to have a tremendous amount of impact. And that is the presentation, the gist of my presentation today. Okay. So as an overview, I want to talk about the transport and energy nexus, looking at electrification. I believe that is inevitable because of efficiency, compatibility, cost, etc. I don't know whether you understand or not, but in fact, transport consumes 30% of energy. The batteries on wheel is about 30 kilowatt hour, which is substantial mobile source or load. EVs are an important part of future energy system, and this will have impact. The question is, how are you going to manage this? So how can we integrate electric vehicle by the technologies which we have today? Is our distribution grid adequate? Can the utilization be improved? As far as the DER and storage is concerned, what type of scale of that is there? Where in the grid it is that? So how can we improve the proportion of renewable generation? And again, whether it be in domestic sector or municipal sector or grid scale storage. A lot of ICT is going to come in. Remember, we're talking about smart grid. So there's going to be flexibility, efficiency, and resilience in the system. Once we have a system like that with ICT, there's going to be issues with cybersecurity. So my question is that, is electric vehicle the problem or part of the solution? What is it? Is it going to help or is it going to be a hindrance? Because it's a major piece of infrastructure. And this will play a significant part of transport network. So the way we access our transport may change. There could be a lot of Ubers coming in, Uberization is what I call, which is, I think is a smart transport, Uber. The problem or solution has technical, commercial, or regulatory. And the most importantly, it could have political dimensions too. So therefore, with that overview, let me start my presentation. I tell you right now, whether we like it or not, the future is going to be electric. And you can think about all sorts of scales. You can think about solar plant with storage power, which would be in shipping size batteries. You can think in terms of your standalone energy system in the vehicle to house type, V2H. You can look at, again, V2G, vehicle to grid. Look at my third figure here, where this Nissan car is supplying this grid. And we can look at some of the switches, which is the control center. So either you can look at the whole storage plant from 20,000 megawatt to 1,000 megawatt to 20,000 watts to 1,000 watts. You can think in terms of 20 times the present utilization. So again, this is my friendly duck. I've shown you that duck before. I don't want to repeat that again. But if I was to increase the PV generation, there's going to be challenge to electrical system, naturally because of duct. There could be over generation during the day, and in the evening, there could be ramps, which is not what we are used to. Look at this. Look at this. After 6 p.m., because of electric vehicle, there's a huge amount of, in 3 hours, it has ramped to 13,000 megawatts. So you can find that it's going to be a huge amount of issues. Look at this is the American one, and this is in Australia. This is our average demand on 2 distinctly different days. So the solution could be time of usage tariffs, because there's a peak shift load. Storage could be the peak shift source, or it could be electric vehicles. So there's going to be a lot of possibility. I want to stress right in the beginning that the present tariff structure that we have, the on-peak and off-peak, may not work at all. We will have to think of a different tariff completely. So the impact of electric vehicle is going to have a significant demand, and there's going to be a huge amount of mobile storage. And please remember, you cannot ignore transport. 30% of the energy consumption is from transport. And I told you 1/3 of the energy, which is normally from petrol these days. So because of efficiency and compatibility and cost, you're going to have electrification. Whether we like it or not, we already have 20% of our new vehicle, which is electric. Domestic battery storage is there of Tesla, Powerwall. Hybrid EVs are there, which is 15-kilometer range. The Nissan Leaf, I told you already, and the Tesla S model. And for a 50-kilometer round trip is going to be 10 kilowatt hour. And just remember, per day, average household consumption is 17 kilowatt hour per day. So compare that with 50-kilometer round trip. The electric vehicle can be a load, it can be a source. And in major capital cities, we will be having about 1 million electric vehicles. So that will be 10 gigawatt per hour per day. Currently, it is only 14.7 gigawatt hour. The extra bit is 10 gigawatt. So your peak demand will go from 900 megawatts to 1700 megawatts. Roughly, it will double. So is there going to be a positive impact or negative impact of EVs? It depends on the number of vehicles. It depends on the size of the battery, when, where, how they are charged. It depends on the time of day. It depends on location. What is the energy source? How they are coordinated? If and how they are managed? How they are used? And the future of transport or commuting. It also depends on the future of the grid, especially with respect to storage. So the impact could be adverse or it could be positive. If it is adverse, there's going to be issues with voltage instability. Peak demand might increase. You might have power quality problems. This will increase your power losses or would increase your overheating in the transformer. But if there's positive impact, the benefit will be V2G technology, which is vehicle to grid. So I think in Australia, by 2036, it'll penetrate about 20% of our market. I believe there's more like 30% now, because 90% of the electric vehicles sold in 2019 was the same as in 2018. And if you look carefully, the electric vehicle sales is going to improve dramatically. What is the possible scenarios? Okay, these are some of the scenarios that could be there. You could have a green source. That's a green source, a PV panel, and you can have your charging station there. This is minimal grid impact factor, because from solar it goes to EV or grid. It could also get from grid. But you can have standalone one only with solar, which is charging the battery and it is charging your electric vehicle. Now, the smart grid. Smart grid has bought an Internet of Energy. The whole amount of smart appliances are going to be there, which will be controllable loads, status reporting. EV would be a sink or source, how the V2G will operate. Operation will become smart when there will be a lot of ancillary services. There will be reliability. There will be service connection, or there will be firming of renewables. The pricing will be smart because there will be value for differentiated pricing. Aggregation pricing will come in and market will be participating. All these will be advantages to smart grid in a distributed system. So there's going to be smart planning where you can defer your infrastructure, minimize the cost, and minimize carbon. And therefore, the past was as follows. The present is like that. The future will be this. This is your electrical infrastructure, right? And look at all the amount of comms that we have introduced and storage that is there. The huge amount of comms will come in. Now, when we're talking about smart grid evolution, let us look at what the enablers are. Naturally, you will have comms, ICT, or control, storage, which will be the EVs. The smart grid is the enabling technologies. And as I told you, a lot of ICT will be there, which will do the monitoring, coordination, and all sorts of things. The storage will be supply equal to demand on average for energy. Smart grid will increase flexibility, efficiency, resilience of the system. And you find the smart grid products will be all the electrical equipment, the ICT industry, the consumer products, and the building industry. So a lot of new products will come in. And look at the price. I told you the price of batteries are going down. So what is the ownership and usage going to be? Say Dr. Chatterjee can purchase his own vehicle. He can have his own vehicle, right? Then he can have own vehicle and he can have an energy subscription using some sort of charging point for charging his vehicle. Or he can have own vehicle and he will play in the energy market, that is V2G. He can supply to the grid through his vehicle. Or he can supply to NIT Andhra Pradesh, okay, through his vehicle. He can supply the labs, the electrical labs that are there in NIT using his vehicle as a storage device. Or he can transport for subscription or rental. So you can find that a lot of opportunities are there. You will find that a lot of this type of service will be there when there'll be auto vehicle, where there'll be driverless cars and it'll be electric vehicle. So it'd be like this is in Singapore. This is a self-driving taxi in Singapore. Okay, this is the Uber in the United States. So what is the forecast? And I want to take the driver as the important thing, because the driver is the important thing. What will the driver think, right? And if you look at that, according to ICOM, there's rapid growth of PV and storage, and there is strong uptakes of EVs. In Australia, 2020, 20% of the new vehicles sold was EV. And I'll tell you, this will multiply dramatically by 2025. Internationally, similar sort of growth is there, whether you look at Germany, France, UK, Netherlands, Japan, etc. So the PV and domestic storage is expected to grow rapidly. Zain, your Baba is calling. Speak to your Baba. Go outside. Okay. Is it a cost? Because I don't believe cost is a problem. If you look at that, if you look at IV versus ICE, you find the fuel cost of EV is 20 times less than that of the petrol-driven car. And the consumption is a lot less. And it is a lot complex. ICE is a very, very complex system compared to your EV. If you look at a 5-year comparison of V2G service, and I just took an example of Nissan Leaf or the Dodge Durango, you find that you get that sort of benefits by using a Nissan compared to Dodge. Okay, if you look at a range, and I'm looking at range in Sydney, okay, and if you look at the New South Wales government travel service, 62,000 vehicles travel to and fro Bankstown each weekday. And they commute about 22 kilometers each way. So they're consuming about 4.4 kilowatt hour per day. And the total energy to recharge all electric vehicles is 205 megawatt hour. And you find that that is 18% reduction in CO2 emission. So the overall results, if you look at the conservative results, you can have an 88% of return commutes in Sydney, which is less than 30 kilometers. And this could be serviced by an average electric vehicle, where the range I told you is between 90 to 160 kilometers. And you can, the level 1 charger, you don't even need to go to level 2 charger. Now, if you look at the United States, that is also not a problem, because you've got a lot of potential for widespread electrification of personal vehicle travel in the United States. Because 87% of vehicle days could be made by an existing affordable electric vehicle. And this is very similar to any other cities in the United States. Charging infrastructure. And this is what is interesting. You can have ordinary plugs or modes, which are various modes, but you can also have WPT, which is a wireless plug. Look at this car, which is there, is wireless plug. The power is being transferred without any wires. You can have EV discharging or charging, which is vehicle to grid or vehicle to anything. Or you can look at charging infrastructure, and that is growing at about 20% per annum in the United States. And overnight home charging can meet most commuter needs. And if you look at that, majority of the user are electric. Look at all that blue that has gone up tremendously on the number of stations that has gone electrically. So home charging has also become, look at United States, home charging is a very big thing, which is there. This, by the way, is not United States, this is Australia, where we have a lot of public station, high power station, in-use station. Now, some of the standards, and I want to mention some of the standards. There are a few standards already in the place. IEC 62196, which is the standard for plugs, sockets, oil plates, vehicle connectors, and vehicle inlets. You can do for the 3 levels, the 4 modes, which could be communication or safety protocol, the GPO, charging, the special cable, or it could be permanently wired. And you can have different type of connectors. 61850 gives you the charging system. ISO 15118 gives you the vehicle, which gives you V2G communication. So that's where the smart charging comes in. So there are a number of standards which has come in, and there are different standards of level 1, level 2, level 3, as I have mentioned before, for different type of chargers, whether it be on-board type or off-board type. The sales, already 1 million cars have sold, okay, which is the plug-in type. And the top-selling model is Nissan Leaf, okay, and going all the way down to Ford Fusion. The top country naturally is the United States. Australia is nowhere near that. The top 10 countries are United States, China, Japan, Norway, Netherlands, France, UK, Germany, Canada, Sweden. China is half of that of the United States. So the United States is leading quite a bit because they started a lot earlier than China. So plug-in cars started in negligible volume about 10 years back. Okay, but as I told you, that they've already crossed 2014. In 2014, they already crossed 1 million sales. These are some of the cars that are there and the prices. I don't want to go into this, but I just wanted to tell you that there is already charts available for different manufacturers. What are the cost of the cars? So then the question comes, the storage. What is the technology? What is the trends and what is the values? Okay. And I don't want to talk about the battery responses, but I just want to give you a figure that we can use. Nowadays, not many people are using supercapacitors, but that is a fantastic alternative. They're looking at lead acid, flow batteries, sodium sulfur, the pump energy storage, the CES one. So there are a lot of energy storage technologies available today. And these are mature technology, very efficient, very cost neutral, and response time is very good. And look at that, whether it is the good one is lead acid battery, right, which you know about. This is a mature technology, right? And response time is in milliseconds. And you can get efficiency up to 90%. Compared to that with lithium ion type, that is the future. Look at that. That's going to be better than lead acid battery type. And I tell you right now, if more research is there, sodium sulfur will be another one that will come up. So what is the value of this to electricity storage? First is the merchant value, then there is the societal value, and then there is value to the customer. So there is value to the private investor. There's going to be driven by energy arbitrage value, and that will determine what is the wholesale market incentive. As far as society is concerned, the whole system will benefit. And the resource cost will be low. So you can see in the United States, they already have projects where they're talking about system-wide benefits. The customer bill, naturally, the bill will be reduced. Wholesale prices will come down. There'll be deferred transmission and distribution cost. And there will be merchant value will be rebated. So reliability will increase. And this will increase the customers and distribution utilities' primary interest. And this could also be a great thing as far as public policy is concerned. So if you look at the system-wide values, you find that although the production cost is much more, look at that one, the capital investment is more in the storage, right? But you can get great value out of this. So the storage deployment brings in benefits much beyond what you had expected. And remember, it consists of benefits, cost, and the bottom one that you see is the net incremental benefits. So if you are thinking in terms of storage, the battery cost is reducing, I told you, is becoming very, very low. Technology is going very fast, and it is halving every 3 years. And that is because the PV prices are going down, inverters are going down, installation is going, everything is going down. So there's no reason to be renewable friendly, not to be renewable friendly. Home battery prices. In Australia, we are already seeing that home batteries are becoming very, very easy to purchase. Although many manufacturers, the prices are still high, so the return on investment might not come very quickly like a PV panel, but the prices are coming down dramatically. And if you look at the technology trends and the values, you will find that there is a rapid growth in PV, EV, and storage. And everywhere you find that there is a transformation going on, the new type of gigawatt installation is going on. 40% penetration of residential battery. 20% of households have got electric vehicles. So by 2035, we will have 2 million electric vehicles here. The new power system infrastructure, they provide, remember I told you about FCAS, frequency control ancillary services, and other network supports. So the local storage will be electric vehicles, which in turn will be vehicle to grid, vehicle to house, etc. The spatio-temporal variability of PV and cloud. There is diversity, and that will reduce the average temporal variability. Will the same effects apply to EV, batteries on wheel? This is a question that needs to be answered. Because if that applies, there might be reducing need to schedule charging. So if you look at the PV and cloud, you find that due to the average temporal variability, the rooftop solar is better on average than large solar farms. But if you look at battery storage with PVs, if you look at the rapid discharge means ramping. A local battery storage needed as PV penetration increases. I was talking to you about that South Australia blackout that we had. When there was a blackout in South Australia in 16 September 2016, and they had 40% of their energy supplied from wind and solar power. They did not have any integration. They had to build in a battery station so that they could have the FCAS, the frequency control, ancillary service stored by 100 megawatt hour battery. So they can increase the PV utilization, efficiency will improve, and the intermittent generation that is there will smooth out. That fluctuation that you see will smooth out. The cost of electricity, that is another feature. Look at the cost. The cost is going down dramatically. The electricity cost for PVs, look at the electricity cost for PV. Generally, the electricity price for household is like that. But with PV, look at how the prices have gone down. And look at the cost with battery. With the battery, the battery cost is extra, but still that is going down. And you will find after 2016, it is better than the normal electricity with fossil fuel. Again, you can look at the levelized cost of the various PVs and winds and biogas and coal and CCGT. So there is a potential impact of EVs, but when, where, and how? That is the various locations that we have got the electric vehicles in the United States. So that is going to be substantial amount of impact with all the charging hubs all around the eastern part of the United States, more than the western part of the United States. So impact on the grid, if there is no storage, then the impact of EV charging on electricity distribution grid will depend on when and where. If there's smart charging, right, this will be the impact, or else if there is no smart charging, this is going to be the impact. And where it is. So that is where you will find that this is if there is demand charging, if there's off-peak charging. In the transport sector, what will happen to the duck curve? You remember I talked to you about duck curve. EV is a significant load or source. It'll depend on charging, where and when and from. At home, you might be able to charge after 7 p.m. using the grid. At home, you can do a schedule with an evening in grid. At car park, you can do it at 12 p.m. Anywhere, anytime, battery, you can use either time-shifted PV or peak shaving. And if you look at all that, the electricity grid is adequate. But what will EV do to the environment? That will depend on grid generation. In Tasmania, we have got, it's completely green. Everything that is produced is green in Tasmania. Depends on how energy is on grid is connected. So 18% reduction can be there of the CO2, even if all coal-fired generation is there. So we can actually, if we are careful, we can reduce our impact even with our coal-fired generation. Our carbon emission can be reduced by utilizing the PV, like having solar powered EVs. Or you can have minimal impact on the environment. That means you do everything which is using renewables. Now the question is that battery storage, what is the best location of this? Should it be close to the source or close to the load? And for that, it depends whichever is varying most rapidly. Is it a charger or battery? Because a low impedance, it could be a low impedance to other sources or load. Is it a rapid response? That could reduce the voltage variation on line. So you can use the electric vehicle as a grid support. Peak shaving is one very important one, especially when we are looking at V2H and V2 grid. That means V2 household and V2 grid. And you can consider if there is no EV, PV or battery, or you can have a 24 kilowatt hour EV plus PV plus battery, or 90 kilowatt EV plus PV plus battery. And you can see immediately that you can do this much peak shaving. This is with the 90 kilowatt hour battery, 90 kilowatt hour EV plus PV plus battery, and that is 24 kilowatt hour PV plus battery. So you can do substantial amount of peak shaving if you look at a house which is running, your converters, your PV, and all that is there, and the house is there, and look at that V2G vehicle is coming from the grid. That's a plug to the grid. What happens in the smart grid system? It will help your power quality because it's going to be coordinated charging of EV from the grid, or it could be coordinated supply from EV to grid. And there are various categories. You can have it as an electricity supply, ancillary services, grid system, end user utility customers, or renewable integration. And look at how the plug-in hybrid electric vehicle influence your energy service provider. In the smart grid, you can look at V2G technology, where your electric vehicle supply is supplying to the grid. Okay, there's the aggregator. You can look at the Edison project, where the electric vehicle integration is there. Or you can look at e-mobility in Berlin, where the electric vehicle is using EVSE, which is electric vehicle supply equipment. So there are all these things which is available. For V2G, it gives you the EV state, the trip data required. You can look at the charging constraint. You can look at other preferences. For the Edison process, you can look at the status, the EV or EVSE data, and the user preferences. For the e-mobility, which is there in Berlin, the public charging, you can look at the EV charging or setup, the price, the user preferences, and various standards. Look at that. All the standards I have mentioned it. I've got all these standards which are already there in existence, can be put in either one of them, the Edison one, the e-mobility one, and V2G one. So even in the smart grid, if you look at the energy and information flow, you can have one way, which is to vehicle, that is start and stop charge, or it could be one way from vehicle, that is location, ID, state of charge, or it could be two way, where there's pricing, time, and amount of charge. Okay, if there's none, then the one way will have traffic information, traffic monitoring can be done, or dynamic routing can be done. From the vehicle, you can run from the vehicle to your house. If it's one way to the vehicle, you can do demand management, smart metering, or transactional energy. If it's two way, then you can do V to grid or V to anything. So you find that all sorts of comms can be used, whether in the transport, in the transportation or the receiving sector. You can look at the various aggregators, the battery management system, EVSE, EVSP, okay, ISO, and all the utilities. And you find you can regulate everything. And the best part, when we are looking at EV and battery management system, you can look at the state of charge, the battery capacity, the GPS, charging and discharging authority, and the various standards. And I've given you all the standards that are applicable to EVs in the smart grid, whether it's a COM standard, whether it's a wireless communication, or whether it's a power standard. So the business model, let's look at the business model, because that is where you decide whether your integration is of any good or not. So if you look at the business model, then you can look at all types of batteries and see what is there, the physical layer, the management layer, and the bushless layer. Business layer. You can look at the physical layer, the management layer, and the business layer. You find this is how the integration will be done. Ultimately, the customer gets the ownership, and ultimately, the customer is the one which has got the EVs, and all the charging points are there. If you look at the business model, you can reduce your battery ownership, okay? You can reduce your customer exposure, and you can look at the advantage for long distances. So you can get a whole business model innovation around barriers to consumer adoption. If you are comparing this with domestic battery, and you look at deposit power, where there is aggregator energy trading services and saving which is there because of storage owners, you find deposit power is the one in Australia, we have that, which gives you grid credit technology. And they've rolled it out in all Tesla home batteries. So solar panel owners now have doubled their saving with new technology that has been launched in Australia. Now, in domestic battery storage system, in Australia, we have got Sunverge and Ergon and Arena. Arena is Australian renewable energy sector. They have got distributed storage, virtual power plant. The asset is owned by Ergon. Ergon is a distribution company, which is leased by consumers. And there is savings. You find how this solar is being optimized, how the grid becomes interactive, how the price is being responsive, and how the demand is being responsive. So the energy storage technologies that I talked to you about, okay, they're the cost. And I did use the word, and I wanted to compare the lithium-ion one with the lead-acid battery. The lithium-ion, the installed cost is between $500 to $750 per kilowatt hour. The lithium-ion is double the price. Look at that. But look at the application of the lithium-ion compared to lead-acid. There's more and more, and it's much more better. Naturally, the flywheel will be most expensive. So we are expecting in another 3 years, the VGI will bring in $21 million. And that is all through the interaction of electric vehicles, which is, I told you, which is only a fraction. Okay, that's going to increase. Big business will bring in to VGI, and that is expected to cross $20 million in the next 10 years. So how does this business model work? The EV owner will become a consumer of a product, business as usual. The EV owner will be consumer of services, where there will be subscription. So the charging will be just like you have it on a mobile phone. EV owner could be prosumer, and I hope you understand what prosumer is. Prosumer means you are also a producer as well as a consumer, and there'll be Internet of Energy where V2G will be there. If you're not an EV owner, then you have to use transport energy services. But this list that I've got, these 3-4 points that I've made, is not exhaustive because there could be a lot of leasing coming in and Uberization is coming in. So business relationship will depend on key players. There could be individual owners. There could be aggregators, retailers, distributors, generators, or suppliers. And the business model will depend on the type of product. This is the Model S that I talked to you about. That'll be $1,687 per month after incentives and petrol savings. It is a premium product, and you can use solar fast charging services. So you can see that you can save substantial amount of money. If you use ChargePoint, the ChargePoint, as I told you, that the ChargePoint wants to build EV charging network, okay? And they will be providing the means from retailer to charging point business model. And therefore, here, the charging services is to the driver, to the public. Anyone can pay as they go. Membership is open. If you have premium services, you go for your third level. You can have it in home. You can have a charging station at home. You can have it in business, say in NIT. I have all the cars in NIT could be charged. And all the fleet of cars that NIT owns can be charged in the charging station in NIT substation itself. In Gold Coast, this is what we already have. We already have this fast charger in Gold Coast. This is 50% quicker than existing 50 kilowatt EV charging station. And they can charge 2 vehicles at a time. And this has already been rolled out. The name of the company is Tritium. And they have done 10 EV chargers across Gold Coast. And that's enough for all the cars over there. Then the other model, which is EVGO, this is subscription based. This is for plug-in vehicle charging. Here you have a 3-year services. It could be installation or access to charging infrastructure. You can do unlimited charging. Again, it can be used at home, mobile, or complete. The NUVVE, which is V2G, which is at the University of Delaware. You look at that. Here is your VSL, that is your EVSE. This is the aggregator. This is the wireless communication, which is optional. There is the two-way communication. So it's not only this is communicating with this, but both of them are communicating with each other, right? There is the Nuve server. Nuve is the name of the company, which is Nuve Smart Grid. This is bringing a lot of advantages to the car original equipment manufacturer, to the car owner, to transmission company, to independent supplier, to distribution company, and to society. And look at all the advantages that is being given by utilizing this smart grid, which is bringing a lot of values. Then the other one is another model where you could see that monthly revenue per car for grid operation is about $150. From electricity car is $40. So we are making a profit about $110. So you are making about $2,500 profit. Either you plug your car into any charger or you charge batteries to 50%, where it's safe to switch to V2G. Or you can switch. If you don't want to do it, you can switch to V2G. That is done automatically. Or you can generate revenue. And then you can get ready for the next trip. So you can see how the whole process, that 1, 2, 3, 4, 5, the whole process works. So in France, they have another way of doing things, right? They have Autolib, where you sign up for individuals or businesses. You can do all your reserve. You can reserve it by making reservation. You can rent it out. You can drive, and you can park. And it tells you where to park. You just have to swipe your car, and that's what it is. So where are we going from here? After all that thing, where are we going? Who, where, what, when, why, how? There are a lot of questions and a lot of answers, right? That's required. But the technical things is very simple. And that is, we need to electrify your transport sector. There are barriers, but the barriers are dropping, my friends. But this will be very important as far as our future electricity infrastructure is concerned, just like renewables. What is the impact of electric vehicles on the grid? My friend, the current grid is disruptive. It has large uncoordinated loads. There is a negative impact. If you are doing off-grid, that is, you are doing only solar charging of electric vehicles via battery, the impact is zero. But if you're using smart grid, there's a positive opportunity. You have large resource of distributed storage, and that is going to give you a positive impact. How do I integrate EV and renewables into electricity distribution? And that requires monitoring and coordination using the various smart infrastructure of the smart grid, utilizing the ICT technology. You have to invest in infrastructure. You have to make changes to your grid. You have to make changes to the rules of how you govern the grid. And naturally, you have to have a look at a different business model. But if you can coordinate the development of transport and energy, infrastructure and policy within the context of developing a smart grid, so you're not looking at Internet of technology, you're looking at Internet of energy. That's where I want to point out. I'm looking at IOE, not IoT. In the commercial sector, there could be potentially multiple participants in the market in a variety of ways. And my friends, there is opportunity for innovative business models delivering balanced cost benefits to all participants. With that, I have completed my presentation. I hope I have done it in time. I just wanted to tell you that it needs mutual support from everyone, my friends. You need to have intelligent transport. You need to have smart grid. You need to have renewable energy. And you need to have technology. Because the technology is going to make you all the policies and the market. I just wanted to know that this will also bring in, it'll bring in a lot of issues for cybersecurity that I have not covered, but at some other time I can cover that. And there are a lot of developments happening in this area. I just wanted to show you some of the developments which are happening. I'm skipping it because that will take, there's one more thing I wanted to mention, and this is the one that is happening in Australia. We are just going to have a new BMWs coming in our country, which will have all the SAV segment. It will be up to 600 kilometers. And this will be an everyday use for a long distance journey. Already the marketing has started for this car. This is up to 200 kilowatts, and it can be charged under 40 minutes, or it can be charged under 11 hours, or it can be charged under 10 minutes. It depends on which charging capacity you want. And naturally, the charging prices will be different. But if you charge with the 10 minutes one, you can have 150 kilometers range in 10 minutes. This is very, very impressive. Okay, and you can drive that, and you can find a lot of power charging stations from Melbourne to Sydney, which is 850 kilometers. We already have 20 to 30 charging points at the moment, so you can drive that without any problem. So that BMW iX, which is there, is a fully electric vehicle. The driving performance is 4.6. Electric range, which is worldwide harmonized light vehicle test procedure, is 630. 630 kilometers this can easily get. With that, Dr. Chatterjee, I'm so sorry. I've gone 8 minutes beyond my time, but I thought I better tell you everything that I knew. And thank you very much once again for the opportunity to talk to all of you.
Thank you, sir. Thank you very much. Now, I would like to request the participants to please interact with sir, because it might be means kind of exposure he is having. It might
Sir,
be a
good afternoon,
lifetime
sir.
opportunity for all of us. Yes, that's good.
Good afternoon, sir.
Good afternoon, Uma Devi.
Sir,
How can I help you?
yes, sir. I am working from Sengundar Engineering College, Tirchangodam, sir. Your presentation is very excellent, sir. Marvelous, sir.
Thank you
I'm
very much.
having small-
We really appreciate it. It's not my presentation which is excellent. It is you who is excellent who is listening to this.
Sure, sir. Sir, I want to know the any open source software available in electric vehicles, sir.
That's a very difficult question. Yes, it is available, but there are a lot of work going on. So which particular part of that you're looking at?
Yes, sir.
It's a, are you understanding me?
Yes, sir. I'm get it, sir.
Like, there's a question which
Currently
has
is not-
come.
Currently
Sorry.
not available, sir. Is there,
No,
sir?
no, not at all.
Okay, sir.
Thank you. There was a question which is in the chat box and I can't see it.
Sir?
Can you read it for me, Dr. Chatterjee?
Yes, sir. Yes, sir. Sir, Hemendra Sharma has asked you, sir, in Indian context, what major hurdles do you see for EV, and do share some suggestions for it?
I've already told you in my first presentation. If you ask my honest opinion, the biggest hurdle and opportunity is the government of India. I use the word government of India. I use the word opportunity and hurdle. Opportunity because they have increased the price of petrol to 100 rupees per liter. I don't know how much is the price in Andhra Pradesh at the moment, but I can tell you throughout India, I've been watching the news. It's anything between 95 to 110 rupees per liter. In Chennai, it's 105 rupees. In Calcutta, it's 100 rupees a liter. In Bombay, it is 103 rupees a liter. In Delhi, it's 102 rupees a liter. Okay, so fundamentally the price is going skyrocketing high, and you can see in the television the amount of people burning fuel pump. It's not the fault of the fuel operators, it's the tax which is 38 rupees of that 100 rupees goes to the taxes towards Indian government. And I told you that is an opportunity, because once when that price has gone to that level, you will find if you had an electric vehicle, you will find that your electric vehicle would have been a lot less costly. And I gave you the figure. I gave you the figure for driving 100 kilometers per hour. 100 kilometers, it costs you 750 rupees in India, according to 100 rupees, 100 liters, or 100 kilometers for 7.5 liters, right? And I showed you, if you had an electric vehicle, you can drive that for 140 rupees. Can you see the subtle difference? I'm not talking from the top of my head. I'm giving you actual figures. I'm giving you your Indian figures. I'm not giving Australian figures. Because in Australia, the price of gasoline is not that expensive. As I told you, we are only paying 120 cents a liter, with $1.20 a liter, which roughly is about, if you take that, it's about, about 30 or 40 rupees. So what I'm trying to say is that it's about 72 rupees, sorry. It's about 72 rupees. And so 72 rupees, and we are a developed country, and naturally our salaries are much, for us, when we do the conversion, we don't do actually 1:60, 1:70. We don't do conversion like that. I always say 1 rupee is equal to $1. You spend the same amount of effort of earning $1 as you spend for 1 rupees. So as I told you, the impediment is Indian government. The prices are going up, skyrocketing high. But this is an opportunity also, because the people will want an alternative, and the alternative is going to be electric vehicles. So that is the opportunity, my friend Uma, and whoever asked that question. And what was that second question that
Okay,
just
sir.
appeared?
Okay,
I
sir.
think
Anyone, sir, Shreya has asked you. Shreya has asked you. Just 1 second, sir.
Dr. Sharma asked that last question. Thank you very much, Dr. Sharma, for asking that question.
Yes. Yes. Shreya has asked you. What are the major impacts on grid during vehicle to grid integration?
I think a stage will come, my friends, that we won't be consumers of electricity. We will be prosumers. I did use that word, prosumer. I've got a whole lecture on when I talk about smart grid and other things, but then I didn't want to make it a big story. But I want to mention that for that person who asked this question, you will no longer be a consumer, you will be a prosumer. That means you'll be producing and you will be consuming. So there'll be two types of customers in the market, right? There'll be two types of customers in the market. One type of customer which will be there will be just buying electricity from the grid. Then there'll be another type of customer which will be buying and selling, buying from the grid and selling to the grid. And then, sorry, there's one more customer. The third type of customer will be there, which will be in islanded situation, which will not buy, which will not sell. It'll, whatever it owns, it'll utilize its own. There'll be three types of customers. Now, I don't think that you will have the last one, too many of them last one, because you will need a supply just in case if everything fails, you would want to get it from somewhere. But you might not want to buy it from the grid. A stage will come when you will have community power, and the community power, the neighborhood power. Say my house is next to Dr. Chatterjee, and Dr. Chatterjee and 10 of his friends and myself, we live in a community. 11 houses are there. We produce our electricity. When Dr. Chatterjee goes to NIT to work in the university over there, and I am sitting at home, I can buy power that Dr. Chatterjee is using. That is called community power. So what I'm trying to say, that you will find that we will have lot of scope for vehicle to grid. There's no doubt about it. So I will go to the university, like I'll go to the university. I will have a car charged with completely with renewable energy. I can sell it back to my university, the charged electricity that I have to run my power lab. I can do that. There's no problem. The only problem will come because I will have less electricity. I'll have to buy to charge my car again. That will be the only problem that I can see, or else there'll be no problem. I cannot use, after discharging my car, I can't go back to Victoria University and then charge it over there. No, that will not be allowed. I can only charge, I told you, I can only charge by using a credit card type of facilities where I'll be allowed to charge, say, between 4 a.m. in the morning to 5 a.m. So that is how the whole thing will be distributed. Yes, vehicle to grid is very, very possible. Vehicle to grid will make our system exactly like being supplying our with batteries. I think that will definitely become. So that is the future, I believe. Have I answered the question, Dr. Chatterjee?
Yeah.
Yes, sir. Yes, sir.
So may I ask a question?
Another, yes.
Sir, I am Dr. Solke from Symbiosis International City, Pune. So my question to you is, sir, that you have shown the duck curve. While plotting the duck curve, it shows that at some part of time the consumption is very less at the lower bottom portion, and there is the neck portion where the consumption is more. So what I understand is that whenever you are having this kind of curve, what is the presumption you have made while plotting the curve? Is it that the vehicles when they're flying, they are not being charged and they will be charged when they're plugging to the grid. Also, there is a possibility that vehicles while flying also can be charged whether with underneath cabling or the roadside things are there where you can battery charge. Is that the presumption when putting the curve or what kind of presumption is there? Sir? The question is that.
Thank you very much, Dr. Nitin, for a very interesting question. That duck curve that I showed you is the typical type of curve. Only that big portion where the peak is high is, look at the timing. And I've shown the timing. The timing says that, say it's a midnight time. At that time, normally we used to have off-peak time when there was not enough being used at that time. So what we did was that at that time we are using our electric vehicle to charge it. And naturally, the consumption has gone very high. That's why that big proportion has gone very high. And you will find that that particular time, that's why I told you that tariff that we have, the on-peak time and off-peak time might not work because your off-peak time consumption is much more higher than the on-peak time. And therefore, you will have to come with a new tariff structure. That's why I said that you will have to think in type of equipment that you're using in your off-peak time, rather than the charge will be based on the type of equipment, not on the time of the day. So that TOU that we were talking about, or we know about, time of use, will no longer be valid. Is that clear, Dr. Nitin?
Yeah, thank you, sir.
Thank you very much, Dr. Nitin. Any more questions, please?
Yes, sir. Yes, sir.
Hello, sir. Good afternoon. Hello, good afternoon.
Yes, Dr. Nitin, is there any question?
No, thanks. I have finished. Thank you, sir. I have finished, sir.
Dr. Nitin, you have your hand up, so that's why Dr. Chatterjee passed it to you. Can you put your, thank you, that's fine.
Anyone?
Hello, sir.
There was one more question that came on Indian context. I saw one question, it went away very quickly. Is that Khalid Imran? He's going to talk to something? Khalid?
Yes, sir.
Dr. Saab, batlaye, hukum kare.
Very good afternoon, sir.
Good afternoon, Dr. Khalid.
This is Dr. Khalid from Vidyavardhana College of Engineering, Mysore, Karnataka.
How are you, Dr. Khalid?
Very fine, sir. It was a very nice presentation. Wonderful presentation from you, sir.
Thank you very much.
Sir, I had a question. How can we bring down the cost of the electric vehicle in the near future in India? Why? Because a vehicle will cost not less than 15 lakhs. Electric vehicle, a good electric vehicle, either by Hyundai or any make. And if there is any other alternative where you can bring down the cost of electric vehicle, which can be affordable when compared to your ICE engine vehicle?
Okay, very good question. I'll ask Dr. Khalid, I'll ask you a counter question.
Yes, sir.
How did you bring the cost of the petrol car by introducing Maruti? Don't you remember that days? Maybe you were too young at that time. But
Yeah,
you
yeah,
had
of course.
Maruti car. Maruti car, when it first came in the market, and I remember because it was going to be manufactured in my state in West Bengal. And so the cost at that time, where all the cars were around 4 to 5 lakh rupees, they were talking about 40 to 50,000 rupees for a Maruti car. They used to call it Jan Gadi or a public car, which was going to be in the market. It didn't work, but I'm just telling you, how did they bring the cost down? You have to bring the cost down by cost engineering practice. And I tell you, Dr. Khalid, the cost of the car, when we used to talk about electric vehicle 5 to 10 years back, we were thinking in terms of between $150,000 to $250,000 per car. Therefore, we thought that we will never have an electric car in Australia at all. We will never use it. Today, we are talking about $30,000. I told you that I just saw an ad in the newspaper about two days back that in Sydney, China is coming up with a new car of $20,000. Our petrol car, I've got a Volkswagen SUV that I drive, and my Volkswagen cost me about $75,000. And I tell you, it was a disaster that I bought that Volkswagen car. I only bought it last year for $75,000. It's a very big car, very nice car. But if you drive an electric car, Dr. Khalid, you will never drive all these rubbish that we have driven in all our life.
Hopefully it'll be affordable in the near future, sir.
Yeah, I tell you that. And when you get married, okay, when you ask for dowry, ask for electric car.
I'm already married, sir. So thank you very much.
You can always marry second time, third time.
Thank you, sir. Thank you very much for your
Thank
answers.
you, sir.
You are very welcome, Dr. Khalid.
Someone has asked you, sir, sir, is swapping of battery future of EV? Is
That is
swapping
a
of
very,
battery future of
yeah,
EV?
very, very interesting question. You go to the service station, instead of charging, you go and you swap the battery, put it. That is very easy. There is no rocket science in that, right? But people are not. You have to be very careful, Dr. Chatterjee. Dr. Chatterjee, it seems with your name that you are from my part of the world. You are from Bengal, is it? It's very good. So I just wanted to make sure that you understand this. Dr. Chatterjee, you have to understand the psyche of a human being. Do you understand my thing? You have to. People are used to. They go to the car depot. They put the hose inside the petrol tank and they fill it up. They don't want to take the battery out and put another battery. Although swapping is the easiest thing in the world, there's no rocket science in that. But they want, psyche says that you want to charge the car. As I told you right beginning, the price of battery is exponentially going down, not exponentially going up. It's exponentially going down, right? And I also told you that the battery which you have got in your car, in the new car, I'm not talking about the old one. In the past, you remember, you used to have 3 years warranty, 5 years. In my Volkswagen, there is no warranty, it's for lifetime. That means the Volkswagen is expecting that the battery will outlast the car. In our country, we don't have cars for more than 10 years. I'm just using that 10 years. So that means the life of my battery in my car today is 15 years at least. Okay. So therefore, I don't want to change. I don't want to change the battery every time that I go. I want to use my battery, right? I want to charge it. And when you go to a petrol station in India, it's a bit tedious because there's an attendant who puts the petrol. In Australia, we do it ourselves, right? And it takes me about 5 to 7 minutes. This will take me 10 minutes to fill up my car. And so what? So my battery will be fully charged in 10 minutes. And even if I have to wait for 5-10 minutes extra, look at the price, 750 rupees compared to 140 rupees. There's a lot of difference, my friend. I saved so much money. And every time you change, say for argument's sake, you bought a battery of Exide, and tomorrow you want to buy a battery of Balaji or something like that. I'm just using a name, you know. I know Exide, I don't know the other companies in India. But you say Exide and you bought a battery for someone else, right? How do I know that the battery that I've swapped is of the same quality and same serviceability as the battery that I've got? Therefore, I would like to retain ownership of my battery, not to swap it with someone. Is that clear, Dr. Chatterjee?
Dr. Kalam, I'm A.K. Mittal. I'm working as a chief engineer in military engineer services. This question of swapping was raised by me only. You know, my idea behind is that, you know, like we replace our LPG cylinders, you know, it is delivered at your home, and then, you know, there are only 4 or 5 companies, and these cylinders can be made exchangeable of the same quality. That's what my intention is. I'm just looking towards that.
Dr. Amit, there is Dr. Amit. I hope I've got your name right, Dr. Amit. But
sir, I'm an engineer. I'm working in military engineer services as a chief engineer.
Thank you very much, Dr. Amit. First of all, thank you very much for attending this presentation. I'm so honored that you are present today. But I want to mention that swapping of batteries is quite different than swapping of the LNGs and the LPGs that you are talking about. We are also swapping LPGs in the gas station, which we use, right? You can do that for batteries too. The only problem is that in batteries, there are so many different manufacturers, and each of them are saying that they have their own IPs, their own, and it depends on anything from $50 to $200 is the price of a battery. I go to a service station and I take my $200 battery and swap it with a $50 battery. I wouldn't like it. That is my problem that I have. There's no problem of what you said, and there's no rocket science in that, Dr. Amit. There's no rocket science. You go there, you've got already fully charged batteries, and you actually just go and swap it, and it's only two terminals, and you just have a spanner and a pliers with you, and you can easily do that. There's nothing extraordinary. Just take it out and put it in. That's all you have to do. And be much more faster. Yes, it can be done. There's no problem. People thought about that, but it's not working.
So your point is well understood, sir. Your point is well understood. I'm just looking towards that. My idea, it may be imaginary. I am looking, I'm looking towards that. If we work towards that all the batteries are standardized at a level so that this swapping can be possible.
Dr. Amit, that is fine. And the other advantage of doing that, which I just remembered, because you come from that background, environmentally, it will be much better.
Yes, yes.
Environmentally, if you look from environmental, because after a period of time when the battery has been exhausted, how do you want to get rid of that batteries? And that is going to be, with all the components in the battery, is it going to be environmentally friendly? There are no environmentally friendly batteries. There is no environmentally friendly PV panels, my friend, with all the silicon which is there. So I don't want to go into that, but waste disposal is a big problem.
Then another advantage we will have, sir, like, for creating a charging infrastructure, we have to spend a lot in maintenance of that. In case of swapping of battery, if it is possible, you can have few centers only over a city where these can be, replaced from a go down or something like that. So a lot of money will be saved on creating charging infrastructure. Sir, my second question is, sir, there was a flash charging technology introduced by ABB in Geneva to run certain buses some couple of years ago. It takes only 20 seconds to charge the bus under a charging station while even passenger boarding the bus. So has it come further, or we are still there only at experimental basis only?
That is an experimental basis. I have seen that. I've seen faster than that also, that type of charging, right? But that is in an experimental stage, and fully developed one, which is marketable. The best one that I could see is 10 minutes.
Sir, what video I have seen, actually, I have just seen one video. It is from ABB Geneva. They are taking hardly 20 seconds. This is called flash charging.
Yeah, I have seen that video too, but commercially it is not available. That's what I'm trying to tell you.
Right, sir. Understood your point, sir. Sir, one more question, if you permit me. Which model has...
Not me, Dr. Chatterjee is the boss. I am just the slave over here.
No, sir. It's a pleasure to have you.
So modest. You have been so modest, sir. So now my question is, which model has more potential, OPEX or CAPEX, particularly in the Indian context, and why?
Okay. Just for the audience to understand, what Dr. Amit is asking is operating expenditure and capital expenditure. Capital expenditure, Dr. Amit, is once only that you spend. The operating expenditure is the one that you are most concerned with. See, when you go and buy a house, that is the first time expense you do, is when you actually buy a house, right? But the operating, how you run the house, that is which is the more of an issue. And normally we always take not the capex, it's only the opex which is there, because you have already built a fund where you have done some sinking fund, etc., where you have built capital to use it for your capex. Whereas the operating expenditure is throughout the period of the time that you own that equipment. So I believe the OPEX is more important than the CAPEX.
Thank you, sir. Thank you for such a wonderful presentation. I'll say not presentation, it was a kind of teaching to us. And
Thank you very much. You
I've
are
done
from a
lot many,
research
I've done lot
organization.
many courses. I've done lot many courses on electrical vehicles. I'm really interested in this field. Just for my knowledge, nothing from commercial point of view. But this was one of the best I have seen, sir.
Thank you very much.
Thank you so much.
Thank you very much. It's very kind of you. You are from the research side, and I would like to learn from you rather than you from me.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you very much for your such a wonderful session. So, do any one of you have any question to
Hello,
ask?
sir.
That is very, I mean, tired now. This means 2.5 hours of lecture sessions has already given. So only 2 or 3 more.
Dr. Chatterjee, this is the third session I've given today.
Yes,
I've already done 7 hours. This is 2.5. This is about 9.5.
Oh my God.
Still going strong.
Hello?
As long as I've got water and my soft drink, which I drink Pepsi, I'm alive. And as long as I've got this voice, I'm an old man, but I think I can survive. So thank you very much, Dr.
One
Chatterjee.
more small question, sir. Can I
Hello?
ask question, sir? One more small question, sir. Can I ask, sir?
Dr. Nitin, please go
Yes.
ahead.
So please, taking further the point which is given by Mr. Amit Kumar, sir. My point is that if you have batteries which can be very cheap in future, where we can just buy battery, use it and throw it, will that be the future in the future, sir?
That is possible, Nitin. That is definitely, Dr. Nitin, that is definitely possible. That the price will be so cheap that you use and throw. Everything is use and throw. However, you must understand that the battery prices are going to come down, and it is already it's really at the rock bottom at the moment. As I told you before, and I want to tell you, don't forget the sodium sulfur batteries. We're only talking about lithium ion batteries at the moment. I don't even bother about lead acid batteries. That is already outdated. I'm talking about lithium ion. But the future will be somewhere where the charging infrastructure will be better. And sodium, and you may have a situation where you may have batteries made of wafers and other devices where you can just use and throw it away. Yes, that is possible. If that is the case, then that is the best option. But again, remember, anything which is throwaway one, environmentally, is it good or not? That is something that you have to be very, very careful about. Or else
Sir,
it is fantastic. Thank you very much.
So thanks for that. So, but one further question on that is that if that is the case, then what about the investment you have made into this charging infrastructure which you're going to have in the near future? So that will be obsolete then. You don't require to have charging facilities.
Look, I don't think it'll become obsolete. The reason why it won't become obsolete because that use and throw type of batteries will take quite a bit of time to develop. And how will the market accept it? That is also a very good question. Like at the moment, we have thin film PV panels at the moment, right? But we don't use them. We are still dependent on silicon structure, either monocrystalline or polycrystalline type structure. Although there is thin film available in the market, but it all depends on how acceptable it is. What is the price going to be? If the price is, if say for argument's sake, I use throwaway batteries and the batteries only last for 2 months or something like that, then it will have no value. However, if that throwaway battery lasts for 3 years, I think there'll be a lot of values in that, Dr. Nitin. I would buy a battery where I can use, throw it away, buy a new one. Yes.
Thank you very much, sir. Thanks a lot for the information, sir. And it's a wonderful presentation for you have given, sir. Thanks a lot, sir.
Thank you very much.
Hello, sir.
Yes, Dr.
Good afternoon,
Siddhartha.
sir. Good afternoon, sir.
Yes, Dr.
And,
Siddhartha.
thank you, sir, for your presentation. It is a nice presentation. And as a student, honestly, I will say that whatever the presentation you have given, maybe somewhere I have not understood all because because so many things are involved while giving a presentation. So many data are there. So maybe we have not understood things, but whatever the fundamentals, what the concept you have explained, from that is the sufficient enough to understand the basic idea of whatever you are saying. But my question is, suppose now we are talking about, everyone is talking about electric vehicle, and we are trying to connect with the smart grid, and we are trying to make it from power flow from electric vehicle to the grid system or community grid system we are talking about. And but we will see that now hybrid electric vehicle is also there. But what about the IC engine? Can we totally replaced by electric vehicle? Suppose after 30-40 years, can it be replaced? And what about it if we can replace it by total by electric vehicle? What about the technology? How will use? How can we use it? That's the question.
Dr. Siddharth, can I ask you a question? Imagine that I've asked you this question 5 years back, and I'm asking you this question in 2021 again. The question that I want to ask you 5 years back, I wanted to ask you this question. And this question is that at that time I asked you, Dr. Siddharth, can you tell me if we will have 100% renewable or will we be dependent on coal-fired plant? 5 years back, what would be the answer? And now what is your answer? Or is it the same answer?
No, sir, the answer will be different. But at that time, we have not that much of expertise in that renewable energy. But based on the situation, the environmental effect, we can now, I can say, yes, we can replace totally by renewable energy. But I want to say, what about that technology?
Hey, just give me 1 minute. 1 minute.
Sir,
so that is possible, right?
Sir, yes, sir.
And now I'll give you the actual implementation. And I'm using that renewable and coal-fired plant. In Australia, 78% of our energy comes from coal-fired plant. And by 2050, we are going to have 100% renewables. Now, my question, what are we going to do with the technology of all that fossil fuel plant? We had best technology. We used to use brown coal. From brown coal, we produced energy. Brown coal, I don't know whether you know the difference between black coal and brown coal. Efficiency of producing power from black coal is 32%. From brown coal is 28%. And to give you difference between brown coal and black coal is solid, black in color, brown is slushy type of material. It is so bad that you will find it is like shit. It smells like shit. It is hopeless. It has no value. Power engineers have made it to run their power plant, but it produces a lot of CO2. It has impact on that. Now, it's one of the best technologies that is there to use for energy purpose, but the environment that we are living, the pollution level that is increasing, has made it certain that we look at alternative way. So what do we do with these coal? Then we ask people like Adani to come to Australia and buy our coal and then pollute India. That's exactly what we are doing. Unfortunately, that is a bad thing. Why are you not going for renewable energy? Why are you still dependent on Durgapur coal and coal from that northeast of India? You know, there are only 35 districts in India and the northeast part of India, which is producing all the coals of India. And in order to keep those laborers happy, and what they call it at the moment, they call it Atma Nirbhar Bharat. That is what they're calling, right? See, I know also a bit of India, so it's not that I'm complete. Dr. Chatterjee is laughing with my Hindi, but anyway, I hope it makes some sense. We are just trying to support those people in the coal plant. That is why we are still running pop. In Australia, you can't do that. And therefore, 100% renewable we are going to have in 2050. The whole country will be like that. And now the question is, what will we do with the technology? Look, technology is always superseded. You always look at the ways that happen. So yes, all that technology of the IC engine which was there, okay, there is always a market for. You will still have engines. You'll still have engines, and you'll still use engines, and that will be. How we are going to use it depends on, and nowadays people have become very, very conscious on the environment that they live in. If it is going to produce obnoxious level of CO2 or pollution in the environment, I will tell you, you will reject it. I give you an example, the best example that I can think of. When you land in Delhi, I feel as if I'm dying. I'm actually dying. I can't breathe. That's the type of breathing I do. And the same type of breathing used to happen in Beijing. Go to Beijing today, and you see that it's complete. The whole air has cleared. And that is the difference. The people will make a commitment. They will force the government, because I have to admit, the government will have to make the final decision. The people will force the government to actually decide what type of energy you use. Exactly in the same manner, the people will decide what type of batteries are going to. Cost and all are all secondary matters. If people want the battery, and Dr. Nitin suggested a throwaway type batteries, fine, there's no problem. If Dr. Nitin can find an alternative for the usage of that throwaway battery that he has used and thrown, that it does not pollute the environment, then there's nothing wrong. Maybe we can come up with some sort of material which is environmentally friendly. Then we can do it. Yes, what will happen to the technology? That technology will be dead. So what? So what? I mean, are you so bothered about that technology, Dr. Siddharth? The technology is there.
No, sir.
You will teach
Yes,
it in
sir.
the colleges, in the universities. That's it.
Oh, thank you, sir.
You're welcome.
Sir, good afternoon, sir.
Yes. Last one, nah, because that is like, it's about 3 hours. It's
Sir,
too
good
much.
afternoon, sir.
No problem. Thank you very much, Dr. Chatterjee, and all of you. I don't want to give individual name because I don't want to forget people. But all of you, you have been a great audience. I've really enjoyed having you. I enjoyed talking to you. I enjoyed interacting with you. And I learned more than what you learned from me. And I really enjoyed it. So with the usual stuff, can I say bye-bye to all of you? And
Sir, good afternoon, sir.
Good afternoon. Well, ours
Sir,
is very much evening. It's night time now.
Sir, is there any vehicle is there without fuel, sir? That means can we drive our vehicles with air like that? Is there any system is there? Is there any research is being going in that direction?
There are a lot of, I don't know whether you've seen all these solar car race and wind car race. We've got a lot of experimental type of that type of cars which are being used for these type of purposes. Dr. Venkata, there's only one small problem that you have. And the one problem that you may have is very simple problem that you may have. And that is because these are intermittent in nature. What happens if you're driving, say, from Arunachal Pradesh to Maharashtra, right? And on the way, the wind stops. So that is what the problem is. Because of the intermittency of the nature of the wind and solar, can you be completely dependent? No. So if there was a battery which is completely charging when the wind is being there, and that could be, you could have a smart system where you can actually convert from wind energy to battery energy, and that would be the easiest way that can be done. Yes, it can be done, but it's at the experimental stage, Dr. Venkata, at the moment.
Thank you.
So now I would like to greet thanks to the power infinity to Professor Akhtar Kalam to be present over here and answer to all the queries. I would also like to thank the participants for their kind patience and their kind participation. So thank you, sir. Thanks to the power infinity to you for being present with us, even with your with so much busy schedule you are having. Thank you, sir.
Thank you very much, Dr. Chatterjee, for the opportunity. And again, all the best. And please try and keep safe, keep healthy, observe safe distancing, and avoid this corona that we are going through. And I hope that I too can come to India. I've not been to India for 2 years because our borders are closed and I can't leave Australia. Bye-bye to all of you and wish you all the best and God bless you. Bye-bye.
Thank you, sir. Thank you very much, sir.
Thank you very much, sir.
Thank you, sir.
Bye-bye. Bye-bye, Dr. Shantanu.
Thank you, sir. Thank you. Bye-bye, sir. Bye-bye. Okay, so it was a very nice session for all of us. So the next session will be of Professor Debashish Chatterjee, I feel, of Jadavpur University. And most probably he'll be joining the session by 3:45 p.m. Okay, so that session will be of 1.5 hours again. So let's join the next session. Till then, stay tuned for the next session. Thank you. Thanks to all the participants.
Thank you, sir.
Thank you, sir.
Thank you very much.